Sometimes things go wrong, really wrong. If we know that something is going really wrong, we need to raise an error and deal with that error later on. In this video, I'm going to show you how to use errors, how to model them, how to catch the errors and handle them, and how they propagate through the process model hierarchy. Let's look at error events. In order to throw an error event, we simply have an end event with a particular label. This end event throws an error. It must have this label because it must have a particular error that it throws. It cannot be a general error, it must be one particular type of error, hence the label. There's only an end event, so naturally we cannot throw an error and then just continue with the process. That's not what errors are for. Errors indicate this went really wrong and you need to stop and do something else. So errors are only end events. To capture an error, we need a boundary event, because we can only capture an error from our own process. We cannot capture errors from other pools or from other sub-processes. So only when it is in me can I catch the error. So only the parent can catch the error. So whenever a child throws an error, it propagates up the chain, up the hierarchy of processes, up to the first parent that has an error handling boundary event. A boundary event can come either as a labeled one, so then you indicate the error that this error event must capture. So if it has a label, it will only capture that label. If it does not have a label, then such an event will capture any error. Let's look at an example. In this example, we have 4 nested subprocesses. So the outer one is D, and that goes on with C, B, and A. Now let's look at what happens when we put a token in the outer process. So not in D, but yet the outer process. In this outer process, we don't have a start event, which means that any element within this outer process will get a token to get the process instance started. In this case, the subprocess D gets started, so it gets a token. Let's just put it here, just to keep track of things. Within subprocess D, which is now active, we have no start event. So we put a token on all elements that do not have an incoming sequence flow. In this case, that is C. So we put a token on C. C is now active. Within C, we have no start event, hence we need to put a token onto every element that has no incoming sequence flows. In this case, that is B. So we put a token on B. For B, again the same story, no start event, hence we put a token on the only element with no incoming sequence flows, which is subprocess A. A has no start events, so we put a token on check stock. And now check stock can execute. This starts executing and it sounds really complex how we got here, but keep in mind that this work is being done by a computer. So it's just a bit of bookkeeping and applying recursive rules. There's no inherent difficulty. Once check stock is done, let's say that condition X holds and we move up. Here we have a message and event that finishes subprocess A. So we send this message and then A finishes. As A has no outgoing sequence flows and in B we were done with executing, there's nothing else to execute, no more active things to do. So let's put the token here on the edge of A. So we indicate that A is done. Now B is also done because there's nothing more. So B produces a token that needs to go into its parent, subprocess C. Subprocess C has an outgoing sequence flow, so there is where the token goes next. C finishes by putting this token out, and now we are in subprocess D. Subprocess D is now done because the token is in the end event. So subprocess D also finishes by producing a token on its outgoing sequence flow. Now we are in the top level process, and this top level process finishes as we have put a token into its end event. Okay, that was quite complex. But let's see how the error events play a role in this. And for that we're going to start over, and I'm going to fast forward through the hierarchy up until we are back at, again, executing check stock. Let's do that and move on. But now condition X does not hold, so we go down in the XOR split gateway. Now we're going to reach an end error event. So as soon as a token hits such an error event, the whole subprocess it is in is cancelled. Everything, even down several layers of hierarchy, everything is stopped. All tokens are removed, all multi-instances are ended, everything. This raises an error. That means that subprocess A goes in error mode. It is now in error, it's not doing anything. It's just propagating the error not in stock. This is subprocess A. As A does not have a boundary event that captures this error, B has to deal with it now. So this propagates to subprocess B. As subprocess B has no boundary event that captures this error, it propagates to subprocess C. Now subprocess C has a boundary event that captures this error called not in stock. So the labels match. So we know within C there's an error being thrown called not in stock, and we have a boundary event that captures it. That means that this boundary event will consume the error and produce a token on its outgoing sequence flow. Now C is back to normal, everything in it is back to normal, and we are in the error handling routine. In this case, we send a message based on end event number 2, and then D is finished. As D finished in a normal way, we finish D by putting a token on the standard outgoing sequence flow. So notice that we do not use this error boundary event in this example. As D finished in a normal way, we are now in the top level process, and that finishes with a token in this end event number 3. This wraps up the error event. We use the error event to indicate that something has gone seriously wrong and we need to deal with that situation. Once an error event is thrown, it needs to be captured, but otherwise it will propagate up the hierarchy of processes until it hits a construct that captures it. We've seen that a boundary event is one of the constructs to capture it. Other options include event subprocesses that will be handled in another video.